Okay, very good. So we can continue. Thank you, everybody, for staying for an interesting topic that you may or may not have heard before. Certainly, you have heard about modeling and simulation. It's been around for many years. I would like to introduce a new approach to modeling and simulation based on a request from our customers, actually. What I'm about to present to you is not something that UL has come up, UL Solutions has come up, but really something that customers had asked us to support them with. So my name is Heike Thomas. I'm with UL Solutions here in Germany, in Frankfurt. I'm responsible for the strategic and portfolio innovation and would like to introduce you a different approach to the certification process, actually. So why modeling and simulation in contribution to the certification or more general compliance? There are good reasons for modeling and simulation, applying it for or in contribution to the compliance. And the reasons may be obvious to you. You know best why modeling and simulation makes a lot of sense. As it relates to the certification, what we learned is that the OEMs, the end product manufacturers, are looking more and more for simulations, for models that they can incorporate into their end models, also including supplier models, which in many cases suppliers aren't yet ready to provide models. And if they do, how can the end product manufacturer make sure that those models are acceptable for what the end product manufacturer needs them? And the system integrators, asset owners, or operators are again looking for simulated models, digital models to be incorporated into their end system models, or any asset really, if you think about data centers, for example, and many other domains. The other aspect that is the constantly changing environment or technology, in fact. The components and end products are getting smaller and smaller, at the same time becoming much more complex. Development cycles are getting much faster and constantly changing modifications. There are many design variances, many customized end products or components. So again, modeling and simulation can make a lot of sense if acceptable in contribution to the certification. And certainly also safety and performance. Digitally, simulation can provide a lot more insights to the product than before. Especially, I mentioned here some examples like the temperature behavior, the spacing measurements, or we get a lot of requests, inquiries about EMC. And finally, it's all about time to market, reducing the risk of non-compliance just before you go to market with your product, and ultimately reducing the cost also throughout the certification process at your end. You can reduce the number of tests, setting up prototypes, and so on and so forth. So here's some additional aspects why modeling and simulation can be really interesting. Most companies have a simulation team, they have product development, and simulation, as I said, has been around for a long time. So why not leverage the expertise and for the certification purpose? The other aspect is the tools. The tools have become much more user-friendly, much more intuitive to be applied, and has really increased in computing power over the last decades. And the pressure for reducing the R&D time is constantly increasing. So with the modeling and simulation and contribution to the certification, you can build in the compliance early on and make sure there are no surprises later on. And also related to the cost, obviously, is the increase or reducing the R&D cost. This is for many companies today one major reason for growing their margins and becoming more efficient. So what does it take for a company like UL, a testing, inspection, and certification company, to accept models in contribution to the certification? It's a slightly different approach than the modeling and simulation that would be applicable during the product development. So what we would like to provide and contribute is this whole governance around the models that you would be submitting in contribution to the certification. And that means it's not just about the results, it's really the whole process. How did the model, how was it built, what risks were taken into considerations, and all the aspects that go into building that model for specific physics. And then being able to trace and explain the results, understanding the data, the mathematics, the calculations behind it is a very important aspect. And then another piece or key reason is the context of use. What is the model intended to solve? What is it supposed to address? Very specific. What is the question that is being answered with the model? And we would like to help establish that trustworthiness into the model so it can be acceptable for a certification decision. And there is no simulation, no digital simulated model without a physical validation. So that goes without saying. We're not looking to eliminate all physical testing, but at the end of the day, it can be significantly reduced by applying modeling and simulation in contribution to the certification. And we introduced a robust verification and validation of those models as an independent third party to help our customers, manufacturers of end products and component suppliers to build models that can contribute to the certification. So here, summarizing the key elements that will make a model acceptable is the context of use, the model V&V approach, the assessment of the modeling approach, very important. Who has built the model? How was the data generated? How were the tests set up and designed? And then ultimately, we will review, assess the submission package and provide the customer with very detailed feedback on whether it's acceptable or what the customer may need to modify. So we put together some key ingredients, as we call it, to really make sure that this is helpful, it's beneficial, and it is enabling our customers with a verified, validated model to really be able to decrease the testing at your end and make the certification process much more efficient. So what does it mean in more detail, the deployment of modeling and simulation for certification? There are different types of predictive models. One is we're focusing on the computational multiphysics, so it's about the EMC, the temperature test, mechanical structural type of simulations. And then the other key approach to the modeling is the statistical machine learning. It's all about the data-based and algorithm-based type of modeling. Most of our customers will come and request our support with the computational multiphysics. Temperature test has been a very popular test to be simulated. It has been well established, something that a lot of customers see a lot of value. And we have created a robust verification and validation framework. This is not something that we had developed from scratch all by ourselves. There's a lot of scientific research already established, a lot of frameworks out there that we were very selective in gathering the key aspects from the different frameworks that are already existing And some have been very well established, some have been around for a long time, like the NASA framework for the verification and validation of simulated models. So based on that, we pulled together a robust approach to be able to verify and validate the models in contribution to the certification. And here you see a number of the different physics types that we have been working on. I highlighted some that may be most relevant to this audience, but not limited to this. Certainly, we are happy to do some proof of concept for whatever you may present us, but those are the ones we are most established, have a lot of experience already, and we'd like to work through the entire supply chain, starting with the components into the end product, and then ultimately going into the system and the assets. Making sure that the models are verified, validated, and acceptable for each stakeholder in the chain. So it's really the predictive models themselves. Just providing a model itself is not sufficient, as you can imagine. There's a lot of modeling and simulation happening with different objectives, different purposes, but it's really the whole process and what all is going into it. Initially, it takes additional effort, it takes additional time and investment, but as you're going through the product lifecycle, introducing design variances and changing of components, it becomes extremely attractive throughout the product lifecycle, because you can always use that verified, validated model for future design variances, component updates, and so on and so forth. So initially, it's more work, more time that has to be understood, but when you go through the life cycle, it pays out. It's important to select the right product or product platform. It's especially interesting for a lot of product variances. Some products have hundreds of variances, so modeling and simulation is especially interesting for these type of product categories. I would say it's not interesting for any product, so be selective about the type of products you want to submit to the modeling and simulation. Also, with very customized products, it makes a lot of sense to apply for product platforms. Again, you have a number of different product variances. This can be very interesting. The other thing that we learned throughout the process is really that the physical validation testing as part of the verification and validation may be a little bit different than the traditional physical testing for the certification. So you may have to add more thermocouplers to really identify the right heat spots. It's a slightly different approach from the certification testing as it is referenced in the standard. It is initially a bit more rigorous to really establish a robust model that then can be accepted into the certification decision. And ultimately, it's about the engineering judgment. The modeling and simulation can provide a lot more product insights. What I also learned from my colleagues in the science and technical teams, they learned a lot about the products. They have been around for 20 plus years and said they never learned so much about the products as they did with the modeling and simulation, which helps them, together with our customer, to provide that robust engineering judgment to make sure there's no remaining risk of non-compliance, but more importantly, of any safety or performance issues later on. So just to summarize, the benefits of validated simulation models are pretty evident. Really reducing the risks is the #1 benefit that we keep hearing, to avoid any surprises just before the customer or the manufacturer is going to market with the new product, but also throughout the product life cycle with the design variances. And then the second key aspect is really reducing the effort, not only in terms of cost, but also the number of prototypes. Ultimately, it always leads to a reduced cost, but the effort in building prototypes, in booking the test lab from the R&D isn't always available. Setting up the tests, running the tests, all these aspects can be optimized by applying modeling and simulation in contribution to the certification process. And then extended testability, so to be very rigorous and trying new approaches for the validation, for the physical validation testing can be extremely helpful. And then applying the modeling and simulation provides a lot more details, as already mentioned, can help with root cause findings much faster, and certainly be the source for more innovation in the product development. Are there any questions? Thank you. If there are no questions now, please reach out. You can. Yes. Yes, certainly, that's the idea. So you have a product, maybe just drilling into a little bit more basics. You have the product, you have the corresponding product standard. The standard will require a list of tests that will need to be conducted. EMC, temperature test. It depends on the product. A lot of times there's mechanical structural tests involved. So with applying the simulation, the customer can determine which test they may want to simulate in contribution to the certification to really reduce the number of tests in the lab and having to build these prototypes. It could be EMC, it could be temperature test, but remember, when we simulate one test, the temperature test, for example, you still have the other tests that you will need to conduct in order to get the certification. So it's just one test. We have projects where the customer would like to do multi-physics. So we have temperature tests, we have mechanical, some vibration tests that can be simulated and will then become accepted into the certification decision. Thank you. And again, if there's no question now, please reach out. You can reach me after presentation, or we can connect after this event. Be happy to connect and do a deeper dive. Thank you.